rainy morning to you guys. We're just jamming with 3.2. Anything there? Okay, make sure. All right. Let's go with it here. Let's continue. I think we left off right here. Is that right? We're going to try to finish up 2, 3, and then 3, 3 today as well. Get the third definition of trig functions. There's 3 so far. So I think we're good with it here. Last time we did this. Everybody okay with number 1? I'm going to just give you one more to try. So draw the angle itself, if you can. Find the radian measurement. And then from there, then name the reference angle in degrees and radians. Number 2. Right, let's get this out of here. Go with just negative 130. Okay. Negative 130. I think we are in quadrant 3. Is that right? Let's see. This would be 135. So it looks like we're just a little shy of that one there. So there's my negative 130. Angle drawn. And so converting it, it's negative 130 degrees. I think we go pi divided by 180, right? Because we're trying to get rid of the degrees. So as long as that's the way I remember it here. So we're trying to put in the degrees or get rid of them. All right, the degree symbols go away. That's great. The zeros go away. That's great too. How about negative 13 pi over 18? Oh, we're good there. I think we'll keep it just like that. So there's part B. So part A here, part B, and then part C. Part C, I think, let's see, reference angles, right? Isn't this little piece right here? It's how far you are away from the x-axis, any which way you are in. So if this is 180 degrees, 130 degrees, I think we're just still 50 shy. Right, 50 shy of that. And then you could also label it if you want to. Negative 130. Let's see, theta hat. Cool. All right. And so let's practice not so much converting 50 degrees into that. Let's practice. Sorry, not converting 50 degrees into radian measurement. Don't do it that way. Try to go from the degree measurement back into a reference angle from your radian measurements here. And so mentally, if we kind of think about this, I think it's even easier here. So pi would be 18 over 18, is that right? So this is kind of works out. If I'm at 13 right now, I just need 5 more to get to 18. And so in this case, everybody okay with the 5 pi over 18? There's my reference angle. A lot easier to do. We'll do it that way.
And so it's either going to go to 2 pi or 0. One of those is going to be what you're going to work out. Okay. We're good there. So let's go quickly the other way. Instead of doing the whole thing, because there's a whole section here, you got 3 things to do. Let's just practice converting. Example 2, example 3. How about this? Just convert. Convert from radian measurement. Let's go backwards with 2-degree measurement. And let's go exact value. So convert radians to degrees with exact values. All yours. Let's see, 15 degrees. But sorry, still waking up. Pi over 3. This would be 7 pi over 5. And this is one of those, as trig students, we're so used to degrees because we've done it all the time. Your natural tendency is going to be like, I'm just going to convert this to degrees all the time. So whenever we do trig functions, try to not do that. Try to think through it with radian measurement in your mind. But as we do that, but just for purposes here, let's see if we're converting to degrees. I think the 180 has to go on top now. Is that right? Pi on the bottom. That's my little unit fraction that I'm multiplying by. Pi's are gone. And how about 180 degrees divided by 3? And how about a good old 60 degrees here? Which makes sense from the previous thingamajiggy that we did, right? 60 degrees is really a third of 180 degrees, which makes sense. This one, not a value that we know very much, 7 pi over 5, but we can still do it. Multiply by 180 degrees divided by pi. All right, pi's are gone. Let's see, in this case, how many times is 5 going to 180? So it's like, I can't subtract. I can divide out these guys right here. I'll sing Jeopardy. Da, 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 da.
I think it's 36.
36, okay. Perfect. So that goes away as 1. According to Grant, it's 36. I can get a second on that, Amaya? Second? Okay. Cool. And all right. And then 36 times 7. Okay, guys, real quick here. Mentally, how we multiply mentally. We learned in grade school, we do this right here, right? We go like this, and we go 6 times 7, right? And then we do the other one, carry, right? If we do mentally, if we do it in our mind, it's actually easier to go like this. You know 3 times 7 is going to be 210. So your 210 is in your mind, then you do 42, and then you add it up. Makes a lot easier to do it that way. So mentally, you actually do it backwards, then you do it on a sheet of paper. 252 is good? Trick of the trade, okay. Okay, that's cool. So without a calculator, that's what we do. Just multiply 180 over pi. Let's get a little more sophisticated. Because radian measurements is a real number. It doesn't really have to have a pi next to it. It's not some piece of pie. Even though pies are delicious, some of them. Convert to degrees to the nearest tenth. So convert 2 degrees to the nearest tenth is my chicken scratching the board here. And so the question is, what in the world is 5 radians? All right, what should we think about in our minds here? Is this right here? Or at least where we're at. This is 0. That should be 1.57. This is exactly pi. And what was this again, anybody? 4.71. Perfect. And then if we go wrap around all the way around the circle, we're at 6.28 because double of pi. Cool. 5 is in quadrant 4, right? About there. That's so we should think about. Anything about 6-ish is getting close to 360 degrees. Okay, 5. Let's convert this guy. I like calculators here. So we are going to go by calculator. 180 degrees and then divided by the pi button. Then you probably want to use the pi button on your calculator as opposed to the 3.14. Though most of the time they'll be the same answers, sometimes not. Okay, try it as well. Now it doesn't really matter which mode you're in on the calculator. That's not an issue here. The mode is really when you're going to do a trig function inside there. All right, can I get a second for 286.5? Cool. And then the question always becomes, what is 1 radian measurement? That's my question. So if I take a radius, right, and I take the exact value of the radius, come on. No problem. If you just take 1 radian, so if you take the radius of a circle, here to here, and then you plot it on the outside, how many degrees is that? That's technically what we're asking. What is 1 radian worth? All right, I think we go still 180 divided by pi. Technically, it's just 180 divided by pi. Awesome, I'd go with that. So funny, it's just like not value, I don't know. It's kind of just funny that way. Nothing spectacular about 57.3. Okay, so remember with degrees, we use it as a 1/10 of a degree. That's one way to do it, right? We also have this whole concept of degrees, minutes, seconds, right? And so let's jam with that. Exercise 5, same process, convert to degrees to nearest second. That's too fun. 2.77. So this is 2.77 radians. All yours if you think you got it. I think we know how to put it into degrees and radians, I believe. So first thing is to convert it here, 180 degrees divided by pi. What does that give us? Sorry, I'm going to say again.
158.7.
And then give you some more numbers there.
7093.
Perfect, yeah. And it goes on and on, right? Cool. So converting to near second here, I think we do take out the 158. That's going to be our degree value the rest of it. So if you're doing by calculator, just subtract off the 158. And then whatever you have left over, multiply that by 60. Is that right? So the leftovers is going to be 0.7093, blah, 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 times 60, which gives us something. Point something or other? 5.5, okay. And then something beyond that as well, or no? Okay. Let me just go like this, dot, dot, dot. So I got myself, let's see, 158. This is a lot faster to do it by calculator here. I'm just writing all the steps down. So the 42 becomes the minutes that we have. And then we take the 0.55, blah, 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 times by 60 again to give us the seconds. And then what is that final answer? 34 round up, okay. And seconds, okay, I'm ready. Because this stuff is not with pluses in between here. So 158 degrees, 42 minutes, 34 seconds. Are we good? We need another one of those, or are we okay? Say again, Hayden?
I'm just not measuring this one down.
Okay. Ooh, all right, taking longer with 3.2 than I thought. That's okay. Cool. Sure. All right, finally we get to where we want to get to. So this is the trig functions here. So can you find for me this example we are on is? Following. All right, I'll start off easy here. So cosine of 2 pi over 3. Without a calculator. There we go. Let them have a leeway and then crush it. Okay, so let's think about this. How's this going to work? And these are fairly easy once we get to know them. So if you talk about 3's on the denominator, you're talking about either a 60 or 30 degree triangle, right? Because you're cutting 180 into 3 pieces, right? For the 4 on the bottom, 4, that means you're talking about a 45, because 180 degrees divided by 4. So that means there's going to be a 45 degree in there somewhere. And so let's kind of think about this real quickly here. The 2/3. That means we take 180 degrees, or half a circle of pi, right? That's pi right there. We're chopping it into 3 pieces, and then we are taking 2 of those pieces. Good there? So it's like this, and we're over here. We're at least past the halfway point, right? We're more than half. We're not at pi over 2, right? We're bigger than pi over 2, right? Because 2/3 is bigger than 1/2. So you know you're in quadrant 2, so as you set this up. Okay, so you also know that if this is 2 pi over 3, that means inside the little reference angle is pi over 3. Are we good there? So here's my little triangle right here that I'm making, right? Pi over 3. And let's see, at first when we're doing this here, it's so much easier just to convert to degrees off your reference angle as well. Eventually you're gonna like just say, oh yeah, it's gonna be here. So let's do the degrees. Let's convert to degrees first, and we'll sort of see the rest of it. Okay. Let's go with this is pi over 3, so it went from here. So it has to be This guy would have to be 60 degrees. Are we good? Because we're left with a pi over 3. That means it's a 180 degrees divided by 3, which is 60. Are we good? That's pi. That's 30. Okay, so our angle measurement here, or our value in quadrant 2 is let's see, that's 1. That's always 1/2 here, right? And opposite of my 60 is √3 over 2. So that means this has to be the negative 1/2 here. This has to be the positive √3 over 2. Are we good there? This is off the 30, 60, 90 triangle. Let me erase this just a little bit later. 5/4 pi. Okay, so tell me, you guys all agree with the negative 1/2? Good there? A lot of mental math in trig, as you sort of can see. All right, let's do it the other way. Let's do it kind of thinking through here. So we're at 2 pi over 3, which is 180 degrees, or pi divided by 3 pieces, like this. We're here. So let's do some mental math here. We're going to go back to quadrant 1. Good there. Are we okay doing that? That takes us from 2 pi over 3 back to pi over 3. And so now, because we've memorized quadrant 1 very, very well, where's my little memorization? Let me do the next slide here. Let me put it all together here so we see. Here's quadrant 1. Quadrant 1 was 0, 1, 0, 0 degrees. This is 30 degrees. This right here is 45, 60, and 90 would be the little corner there. Okay, I think we had it like this. Cosine goes down each time. All right, agreed there? Are we good there? Sine goes up each time. So 0, that's 1/2. That's √2 over 2, √3 over 2, √4 over 2, or just 1. Good? Let's kind of put this together here. So let's convert these guys into radian measurement here. So 30-degree angle. 30 degrees angle is really just 160 divided by 6. I'm sorry, 180 divided by 6. 45 is going to be a pi over 4. 60 is a pi over 3, because technically 180 degrees divided by 3, right? And then the whole 90-degree angle here would be pi over 2. Are we good? Okay, so let's jam with this. This is what you probably should have memorized, or memorized very, very well. So let's go back to our problem here. So we're at 2 pi over 3. We're here. We know at 2 pi over 3, that means we can convert it back. The height of it is the same as we converted back to here. If we do that, we're at pi over 3, which is this little value will be our next slide, which is a 1/2 √3 over 2. And since we're in quadrant 2, it's going to be a negative 1/2. Are we good? A lot of mental math there, but it'll get used to it. Just kind of as you're learning how to play a new instrument, it's really difficult at first, and then it's like, oh, that's pretty easy. or volleyball. Okay, are we good with the -1/2 here? Did you guys write down b already or no?
So, with figuring it out, like when I first started, I just converted the 2 pi over 3 into degrees.
Mhm.
And then I thought I could like go backwards and solve it.
Absolutely.
So like then find is that okay? Like find the theta hat and then convert it back into radian or whatever when I'm done.
Sure. Let's see. You can. I'm going to try to have you guys not do that because
Okay.
eventually you want to think about it in radians. And when we get to calculus, we hardly look at degrees. Everything is in radians because I want everything to be a real number versus a real number. Physics, even though they do degrees sometimes, thinking through things here when the angle measurements, but really when you're talking about trig functions, you're talking about radian measurement because you want real answers and real numbers to work with. Okay, we're good there? So try not to convert to degrees. Let's do one more here of this guy since b. Let's go with sine. I think I'm gonna go 7 pi over 3. Okay, let's see how this works here. Again, try not to convert into degree measurements. Bless you, bless you. So 7 pi over 3, bless you again. Let's see, that is, hey, that's already past 2 pi, isn't it? That's 2 pi right there, isn't it? 6 pi over 3. 3 goes into 6 twice, so that's 2 pi. So we're actually past 2 pi. We're back into quadrant 1, the other way around. So see if this makes sense. That means if I go around like this, and I'm a 1/3 beyond it. So it's like that. Are we good? Okay. And here's where the memorization comes in. Look at the little chart if you need to here. We're going to take a look at the chart and say to ourselves, hey, you know what? It is a 1/2 again, right? Root 3 over 2. This time we're looking for sine. All right, and are we okay with the root 3 over 2 this time? Yes or no? Talk to me. Okay. Okay. Got one more for you. Sort of think through here. Tell me if I'm going too fast. Cosine. Cosine of 5 pi over 6. Let's see if this makes sense here. Let's see. I am just a little bit shy away of pi, is that right? So I have to be here. This little angle right here. This is 5 pi over 6. That means I'm at pi over 6 over here. That's my little triangle that I can form. So let's do this here. Let's convert this triangle back into quadrant 1 again. Use a little different pen color, just because I can. Ha, ha, ha. Pi over 6. And what's my coordinates for a pi over 6? Absolutely, are we good? Cool. All right, I'm looking for cosine, so I'm looking for the x coordinate here, and because I'm in quadrant 2, negative or positive. Keep the sign, change the sign. Change the sign. So negative root 3 over 2. Okay. Let's do this. This might be a worth it here. I know we've done it before, but try to do this here. Try to do this without looking at any notes. Try to do this from your own mind here. Can we fill out this little chart? So I don't want degree measurements here. Just real quick here. Can you fill this chart out using only radian measurements? Give me the values there for sine and cosine function and put in the radian measurements only. Charlotte, was that Marie that came by? Or that was Mom?
That was my mom.
Okay, okay.
Genius. She knew that I left my coffee in the
That's cool. She was all bundled up. I did not know who it was.
Yeah, she was over watching my mother doing the like RV fitness assessment, ROTC this morning, so they're all over.
Oh, cool. Yeah. Great weather to do it in.
Oh yeah.
It's kind of like playing.
2 miles to the next day.
Playing mud football. Yeah, I always love that. Okay, so hopefully you guys did it here. And kind of just from your own mind, can you just kind of put all the pieces together because it'll help a lot when you put this in. This is kind of like what you should have in your mind here. So let me start off 0, 1. I'm going to put in my root 3 over 2, root 2 over 2, 1/2, 1, and then I go backwards the other way. So 0, sorry, how about 0 here, 1 there, root 3 over 2, root 2 over 2, 1/2, done. Cool. So let me put in my radian measurements, that's 0. This would be pi over 6. It's the small angle that's formed. It's the triangle that's formed so that the x coordinate is bigger than the y coordinate, or the length across the x-axis is greater than the length across the y-axis. That's cool. This guy then is pi over 4. That's the 45 degree. Pi over 6 is pi over 3 is the big angle that's formed. So in this case, it's when the y value is going to be greater than the x value. And then pi over 2. Okay, I think we're ready for this one to do a little faster. Still copying it down, go for it. So that's what's shadowing around. Pi over 4 is going to work easily. Any pi over 2 values are going to work easily as well, because they're just going to be along the axes. But we'll just work with pi over 6, pi over 3. Those are the toughies.
What's the middle one in between pi over 5 and pi over 6?
Pi over 4. It goes, so it goes pi over 6, pi over 4, pi over 3, and then pi over 2. No pi over 5 in there. That's no fun. Okay. What letter are we on? I think C, D. Okay, D. Let's just try it one more time here. Let's see. I'm going to go with sine of 11 pi over 6. There it is. So can you draw it where it needs to be? Draw it back into quadrant 1, and then get the value of it. And the denominator is the key. So 11 pi over 6. That means it's the small angle, is that right? It's the small angle close to the x-axis. So if I were to draw it here, it's just shy of pi, 12 pi over 6. So it's actually right here. It's just shy of the 2 pi. Here's my 11 pi over 6. I mean, my reference angle is pi over 6. And so if I convert this back into quadrant 1, here's my pi over 6. And then I know this one right away. Boom, boom, can you give me coordinates? Perfect. Okay. Now I'm trying to figure out sine. Sine is my y value. And I'm in quadrant 4. Okay. Is that getting a little easier to do? Here's our stretching the mind there through it. Okay. So let's do a quick easy one, and then we'll get to the end here. D, E. Sine. What's sine? Sine of, there it is. I think that's the one we start off with. That was supposed to be our B from a long time ago. Took a little detour today. All right, that denominator 4 gives it away. Da, 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 da. You know what that should be. You also know the reference angle. And done. By sum. Too easy? Okay, if it's like soup, Mr. Ng, if this stuff is so easy for me. So what you want to do is you want to just do it with one eye open. Just makes it just a little bit more difficult. Not by much.
Wait, so then would it be in quadrant 2?
Let's check it out. So 5 pi over 4, which quadrant is in? Which quadrant are we trying to put it into? We're trying to put it into quadrant 1, but what quadrant is it in right now? 5 pi over 4. Ooh, cool. Let's have fun here. Let's go. 5 is bigger than 4. So then I know it's bigger than pi. So then I know it has to be bigger than the 180 degrees, right, marker? Right? It's in quadrant 3. All right. Okay, I agree with that. So, and then whenever we count, that's right, we're moving on to a new denominator here. So let's go for it here. So if you slice things into 4 pieces, that means you're in 45-degree angles, right? So if you wanted to count, this would be pi over 4 is right here, right? 2 pi over 4 would be right here. 3 pi over 4 would be here. Here's 4 pi over 4. And here's where you got to 5 pi over 4. You're in quadrant 3 with a reference angle of pi over 4. And what we do is we swing this back around into quadrant 1 just real quickly here. And then really we know that these two are root 2 over 2, right? They're the same, right? Because it's a 45-degree angle. Cool. So in quadrant 3, you almost like don't even need to bring it back into quadrant 1, right? Because you know if you have a denominator of 4, you know it's root 2 over 2 for our trig functions. And so then you know it's a negative because you're in quadrant 3. So then you really just need to figure out which quadrant you're in for the sine value. Okay, are we good? 5 minutes to go. Let's just do one more here. Are we on exercise 7? 6? 7. Okay. Oh, I'm glad we took the extra time for 3.2 here. Yeah. Give exact value. There you go. So let's see how much time we have. 4 minutes. I go with that. 1/2 cosine of 2 times x if x is equal to pi over 6. All right, all yours here. So we've got 1/2 cosine of 2 pi. I think it's setting us up for graphing, I believe. Yeah, next chapter. All right, some algebra here, right? So we'll go with cosine. We got 2 times pi over 6. Oh no. Hold on, this is supposed to be without a calculator. No calculator on this one. It knew what it had to do. It had to die. So let's see, 2 times pi over 6, I believe those reduced down to 1 and a 3, is that right? Okay, how about I got 1/2 times cosine of pi over 3. Cosine of pi over 3. Small angle or big angle? It's the big angle, right? It comes up like this. Okay, so for big angle, the coordinate's 1/2. Say again, Jordan?
I just said I like how that's the classification. Big or small? This is very crucial.
Okay, go with it. We're trying to find cosine here.
Is that square root of 3 over 2?
It is the square root of 3 over 2 for the y value. I'm going to go with cosine value, so that's a 1/2 here, so it's going to be 1/2 times a half. Everybody okay with the 1/4? You're good there. Okay. Okay, and we've got to do a negative angle too here. And we're at to here. Okay, A's. Everybody good with A? Anybody else need more time with A? Nope. Okay. B. Let's see. I don't know. 3/4 times. Ooh, any fun stuff here? I guess so. Yeah, we can do this here. Minus. This one has to work out though. Sine of 3 times. Yeah, we do it like that. So 3/4 subtract sine of 3 times x, where x is equal to pi over 2. All right, and we're running out of time, so go for it. I'm going to try to fit this in here. So first of all, we've got to figure out what our angle measurement is. Putting all this together here. Multiplying by 3 causes us to have a 3 pi over 2, is that right? So there's, okay, we got to figure where in the world is 3 pi over 2. So we have a denominator of 2 this time. So that means we're at the corners, is that right? So pi over 2 is right here. 2 pi over 2 is here. 3 pi over 2 is down here. That's what we're looking at. Oh, nice. Those are called quadrantal angles. And we get our value right here really fast. That's a 0, -1. And we get ourselves 3/4, subtract a -1. And 3/4 plus 4/4 makes 7/4. And are we good for our final answer? Maybe. True. I think so. Anybody agree with me?
Wait, what is the last part then?
Sure. This is 3/4 plus 1, because it's subtracting a -1. Then it's 3/4 plus 4/4 equal to 7/4. So that's our final answer. And let you guys out 3 seconds early. Okay.